Okay, let's unpack this. Have you ever paused to think about what it really takes to secure critical government installations around the globe?
Hmm.
We're talking military bases, sensitive federal facilities. I mean, it's far more than just, a few cameras and alarms.
Absolutely. Way more.
Today, we're doing a deep dive into an actual government performance work statement, a PWS, specifically for electronic security systems, or ESS.
Right.
This document, it's basically a blueprint, and it offers a really fascinating glimpse into the meticulous detail required to ensure safety and security on a truly global scale.
And it's amazing how these documents, which, yeah, they can seem pretty dry on the surface, actually reveal the immense complexity and the strategic importance behind securing these sites.
Yeah.
It's a far more comprehensive approach than most people could probably ever imagine.
So our mission for this deep dive is to pull out the most important insights from this intricate PWS.
Yep, the key stuff.
We want to show you the layers of technology, the oversight, the human expertise involved, and hopefully, give you a few aha moments about the unseen efforts that underpin national security.
Definitely. There's a lot hidden in there.
So when we talk about electronic security systems in this context, what exactly are we encompassing? It sounds incredibly broad.
It absolutely is, yeah.
Yeah.
This PWS dictates a vast array of systems that extend well beyond what you might think of as just security.
Okay.
It covers everything from like the procurement and installation to the ongoing service and maintenance of comprehensive physical security measures and force protection technologies.
Can you give us a sense of the sheer variety here? Like, what kinds of systems are we actually talking about?
Okay, so the scope is truly extensive. We're discussing core ESS applications like electronic access control, ACS, right? Video surveillance systems, VSS, what a lot of people know is CCTV and intrusion detection systems, IDS.
Yeah,
Or-
basics, the
or-
standard things.
Yeah, but then it also stretches into automated control systems, things like building automation systems, BAS, fire alarm systems, FAS, life safety systems, even highly specialized chemical, biological, and radiological detection and response systems.
Wow.
And then, maybe surprisingly to some, mass notification systems, MNS, are also included.
Mass notification systems. That's an interesting addition.
Right.
It tells me it's not just about preventing an incident, but also about managing and communicating effectively during an emergency. What's maybe the biggest challenge in integrating something like MNS with, say, access control?
That's precisely right. And, a critical element that really emerges here is the mandate for deep integration of all these various subsystems. The challenge, it lies in making them work seamlessly together, creating a truly cohesive, layered security environment, rather than just, a collection of separate systems that don't talk to each other.
Got it. So it all has to function as one unit. Now, this isn't just for one base, is it? The document points to something much, much bigger: worldwide support. When you consider that global reach, what kind of unique operational complexities does that introduce for the contractors?
Well, what's truly striking is just the sheer scale of the operation. The U.S. Army Engineering and Support Center, Huntsville HNC, is actually designated as the ESS Mandatory Center of Expertise, the ESS MCX.
Okay.
Their responsibility is to provide worldwide support, not just DoD, but other federal agencies, even non-DoD agencies sometimes. This isn't just a domestic thing at all.
Worldwide is a big word. Can you give us a tangible sense of just how global this reaches? Like, what kind of locations are we talking about?
Yeah, it's huge. The contract demands responses to multiple requests in diverse locations across both the contiguous United States, CONUS, the lower 48,
Right.
and outside of the contiguous United States, OCONUS. The PWS explicitly lists OCONUS locations, including Alaska, Hawaii, other U.S. territories, and then numerous foreign countries like Australia, Bahrain, Belgium, Germany, Japan, Jordan, Kuwait, Poland, Republic of South Korea, Saudi Arabia, Turkey, the UAE, and the UK.
That geographic scope is just immense. And the contract itself, it's designed for the long haul, right? This isn't some short-term gig.
Correct. Yeah, the base contract period is 36 months, so 3 years. But then there are 2 optional 24-month periods. So, added up, the overall effort can easily span many years.
7 years total, potentially.
Exactly. And the work is issued through individual firm fixed price task orders. This long-term commitment is really essential for ensuring continuity and sustained maintenance of these absolutely critical global systems. You can't just set them up and walk away.
Makes sense. Okay, so we've looked at the sheer breadth and the global scale. Now, let's peel back another layer. How does a document like this ensure consistent quality, ironclad security, and importantly, worker safety, no matter where they are or what system they're working on?
Right. This brings us to a really fundamental point.
Yeah.
How do you ensure consistent quality across such a vast and critical undertaking?
Right.
The PWS, it defines a very clear operational boundary between the contractor's quality control, their QC, and the government's quality assurance, the QA, two distinct things.
So the contractor is explicitly required to have their own rigorous internal quality program. They can't just wait for the government to check things.
Exactly. No waiting. The contractor must develop and implement a corporate quality control plan, a QCP, within 30 days of getting the contract award.
Wow, quick turnaround.
Yeah. This plan details their inspection procedures, their record keeping, how they actively prevent defective services. And then for each specific project, like a task order, a site-specific QCP is also mandated.
And how does the government verify all this? How do they, check the checker?
So the government performs QA inspections. These are based on performance standards and acceptable quality levels, AQLs, that are defined in the PWS.
Okay.
If a process or maybe a work product falls short, or if there's a safety noncompliance, they issue what's called a corrective action request, a CR.
A CR?
Right. And what's interesting is the tiered response system for these cars. A critical nonconformance, something that might create hazardous conditions or stop a vital mission, requires a response within 24 hours.
24 hours. That's fast.
Very. A major nonconformance gets 72 hours, and a minor nonconformance allows up to 15 business days. This detailed categorization, it really underscores the criticality and the urgency involved.
Absolutely. You can see the priorities.
Mm-hmm.
Now, beyond just quality, the core purpose of these systems is obviously security. How does the PWS tackle security, and what forms does it take beyond just the physical equipment itself?
Well, the approach to security outlined here is incredibly multifaceted. It goes way beyond just the physical ESS gear. Firstly, there's information security. The contract often involves handling classified information. Could be secret or even above, and that's spelled out in the task orders. So contractors must comply with the National Industrial Security Programming Operating Manual, the NISPOOM.
And for those maybe unfamiliar, NISPOOM essentially sets the gold standard for how private companies handle classified government info and personnel access, right? It's kind of the rule book for secure collaboration outside the government itself.
Precisely. Yeah, it's the absolute baseline. It ensures sensitive data and facilities stay secure even when managed by contractors. It covers personnel clearances, facility clearances, how you handle the information.
Got it.
Then there's IT system security. For any unclassified IT access just getting onto the network contractor.
Yeah.
Employees need a minimum of a Tier 3 Federal Investigative Standards investigation, an FIS.
Okay.
And they need that Common Access Card, the CAC.
Right, the CAC card.
Got it. And then there's the equipment itself. I think you mentioned the NDAA.
Yeah, I remember reading something about the equipment itself and the National Defense Authorization Act. That sounds like a pretty significant supply chain security measure baked right in.
It is, and it's a critical one these days. All hardware materials must comply with the John S. McCain National Defense Authorization Act, specifically from fiscal year 2019, Section 889.
Okay.
This basically means equipment cannot contain certain banned telecommunications equipment or services, particularly from specific named companies. And it can't even employ components from those banned companies deep inside the device.
Wow.
It's a very specific and proactive measure to mitigate supply chain risks. A huge national security concern now.
Definitely a sign of the times. Okay, so given the nature of installing and maintaining these systems, often in complex, sometimes potentially hazardous environments, worker safety must be absolutely paramount. How stringent are the requirements for that?
Oh, the PWS is exceptionally stringent here. Extremely. Contractors are required to comply with the U.S. Army Corps of Engineers Safety and Health Requirements Manual. That's EM 385-11, the big one. Plus all the OSHA requirements, specifically 29 CFR 1910 for general industry and 1926 for construction. And of course, all federal, state, and local laws. And the rule is always, the most stringent requirement governs, whichever one it is.
That sounds like an incredible amount of pre-work and planning. It really makes you think about how many layers of preparation are involved just to, turn a wrench or run a cable on site.
Absolutely. You nailed it. Contractors must develop a comprehensive corporate safety and health program, an SHP. That's the overarching plan.
Okay.
And then for each specific project or task order, they need a detailed accident prevention plan, an APP. This is basically their robust roadmap to identify and avoid hazards before they happen on that particular job.
So like a plan for the plan, almost.
Pretty much. They even need a site visit APP, sort of a quick version for initial assessments, and an activity hazard analysis, an AHA, for any specific work activity that might introduce new or unusual hazards not covered in the main APP. And they're also required to employ a dedicated site safety and health officer, an SSHO, at each project site. That person's job is safety.
Full-time safety person.
Full-time safety person. And if hazardous materials are unexpectedly encountered, all work has to stop immediately, period. And the government must be notified within 24 hours. It's all about building that ultimate safety net before the first piece of equipment even arrives.
That makes perfect sense given the stakes. Okay, so we've established the what, the where, and the really stringent how of these contracts, the quality, security, safety frameworks. Now let's shift focus a bit to the concrete actions. What specific services and tasks are contractors actually performing on the ground to bring these elaborate plans to life? It's not just bolting stuff to walls, right?
No, not at all. That's an excellent way to put it. The tasks really cover the full life cycle of these systems. This includes preparing detailed documentation, like drawings, wiring diagrams, the blueprints, then procuring and installing both the software and the hardware. And crucially, ensuring all software undergoes the DoD Risk Management Framework process, the RMF, to ultimately obtain an authority to operate, or ATO.
An ATO. That sounds like a pretty significant cybersecurity hurdle just to get the system turned on. Are there, common challenges or surprising complexities that pop up when contractors go through that rigorous cybersecurity approval process?
Oh, it's definitely a significant process, yeah. An ATO is essentially a formal declaration by a senior official that a system is authorized to operate on a government network. That means it's met rigorous cybersecurity requirements.
Right.
And the contractor, they bear the responsibility for providing all the necessary documentation for this. That includes a comprehensive system security plan, various supporting artifacts like a disaster recovery plan, an incident response plan, detailed hardware and software inventory lists. That's a lot of paperwork. And they even have to perform what's called scan, fix, scan testing. Basically, continuously scanning for vulnerabilities, fixing them, and then scanning again to verify the fix. It's a constant cycle of vigilance throughout the system's life, not just a one-time check.
That's incredibly thorough, especially that ongoing vulnerability testing piece. What about the more, let's say, traditional physical work? What else falls under their scope?
Right. Beyond the digital, there's substantial physical work. This includes doing engineering surveys of the sites beforehand, developing system databases and the graphical interfaces the operators use, conducting all sorts of tests, factory acceptance tests before it even ships, pre-acceptance tests on site, full functional tests, even burn-in tests to stress the system.
Okay.
They also perform minor construction if it's needed to support the equipment installation, maybe pouring a concrete pad, running conduit, that sort of thing. Then, post-installation, the contractor provides the operation and maintenance manuals, the O&M manuals. They do comprehensive training for the system users and administrators, and then they offer ongoing maintenance and monitoring services. And there's even a warranty required for systems and workmanship, typically for 1 year or longer if the commercial warranty is better.
So it's definitely not just install and walk away. It's a long-term relationship.
Absolutely, full life cycle.
Now, this sounds like it requires far more than just a few technicians. It really demands a real dream team of experts with diverse skills. What kind of personnel are actually required for a contract like this?
Yeah, it absolutely highlights the inherently interdisciplinary nature of modern security. You need lots of different skills. The PWS mandates specific key personnel with very detailed qualifications.
Okay.
For the base contract, the main umbrella contract, they need a program manager with pretty extensive experience, minimum 10 years relevant experience, a bachelor's degree, and they usually want PMP certification.
Project management professional.
Okay, exactly. They also need a senior contracts manager, naturally, a senior electronic security engineer. This person needs specific engineering degrees and often certifications like a professional engineer, PE license, or maybe a certified protection professional, CPP, and a dedicated quality control manager. That's just for the main contract oversight.
And then for each individual project or task order, do they bring in additional specialized roles for those?
Yes, absolutely. Individual task orders may require their own project managers, more electronic security engineers, and even highly specialized roles like security system engineers, SSEs who focus just on the security system design, and network specialists because everything's networked.
Right.
And these network folks, they have to meet specific DoD Information Assurance Workforce Improvement Program certifications. That's DoD 857.01-MO. Things like Security Plus or CISSP, depending on the role.
Okay, specific IT certs.
Yep. There's also usually a site superintendent required for the day-to-day on-site management during installation. And crucially, all key personnel need at least a secret security clearance just to start, with some task orders requiring top secret or even higher levels depending on the site and system.
So it's not just about building and maintaining these complex systems. There's clearly a continuous layer of reporting and management involved, too. I saw something about detailed manpower reporting. Why is that level of detail so critical?
That's right. The contractor is required to report detailed manpower information. This includes not just their own hours, but subcontractor hours and dollars too, into a secure Army data collection site, usually the Contractor Manpower Reporting Application or CMRA. This is done regularly, typically monthly or quarterly, depending on the contract specifics. They also have to participate in post-award conferences, periodic progress meetings with the government team, and provide various other reports, things like after-action summaries if something goes wrong, installation progress updates, trip reports. Even travel expenses are meticulously tracked and have to be proposed up front for each task order.
So why such granular reporting? What's the underlying driver for that?
Well, it really boils down to a few things. Transparency is key, accountability, and ensuring most efficient and responsible use of taxpayer dollars, especially given the global scale and the critical nature of these operations. It allows the government to maintain a clear line of sight into every aspect of the project, how resources are being used, and whether progress is on track. No black boxes allowed.
Makes total sense. Complete oversight.
Wow.
What an incredible deep dive into this unseen world of securing our most critical installations. It's really so much more intricate and comprehensive than I ever imagined, covering everything from highly specific cybersecurity protocols like RMF and ATOs, the supply chain rules with NDAA compliance, to the rigorous hazardous material handling and the need for this highly specialized cleared workforce.
Indeed. Yeah, this PWS, it isn't just some contractual document collecting dust on a shelf. It's really a living blueprint for comprehensive, layered security operations that truly underpins national defense and critical infrastructure, not just here, but across the globe.
You know, what truly stands out to me now is how these detailed, often unseen, almost bureaucratic mechanisms, the PWS, the QC plans, the reporting, how they truly underpin our global security and national defense. It goes so far beyond just the visible hardware, the cameras and gates.
Absolutely. The process is the protection in many ways.
So for you, our listener, maybe consider this. How much of our day-to-day safety and security actually relies on these meticulously defined, executed, and audited contracts? These systems and the people running them, working silently in the background, around the clock, all over the world. It's really a sobering thought, isn't it? And one that highlights the immense, continuous, unseen effort involved in keeping us all safe.
A really important perspective to keep in mind.